Okay, in this video, we're just going to be reviewing normal distribution. So before we actually get into normal distribution, I'll just quickly remind you about what standard deviation is. So standard deviation is a measurement of how spread out or how close together a data set is. So, and it's all in relation to the mean. So if we recall, mean is what we call a measure of central tendency. So how we calculate it is we add up all of our data points and divide by however many data points we have, and that gives us our mean. So in your textbook, depending on the context, mean might be represented by an X with a line over it called X bar, or by the Greek letter mu. So it's that sort of fancy, looks kind of like a U or like a writing kind of M sort of situation. Anyway, so it'll be represented by one of those two things. And then standard deviation compares the data set to that mean. And if you recall in class, we went over the complicated calculation to get that. It's really time consuming, and like I said, we're more interested in interpreting the data and understanding what the numbers mean than in spending a lot of time calculating them. So standard deviation just tells us how closely grouped data is around the mean. So if the standard deviation is really small, it means all the numbers are really close to the mean. If the standard deviation is a large number, it means that all of the numbers are farther away from the mean. And so standard deviation will always be represented by a lowercase sigma, so it's right there. And both of these are important for normal distribution because normal distribution depends on the mean and the standard deviation. So normal distribution means that all of the data is symmetrical about the mean, so the mean is like the middle point of the data, and then everything else is sort of symmetrical around it, and certain percentages fall within a certain standard deviation of the mean. So we'll just look at that. Okay, so this is what's called normal distribution. So again, we've got this mu that represents the mean. So this is the midpoint, and then again, most of the data, so 68%, is within one standard deviation of the mean. So if we add whatever the standard deviation is to the mean and subtract it, so 68% should be within that area. And again, because it's symmetrical, you're going to have 34% on the side above, 34% on the side below. Then you add another standard deviation, we're going to get another large section, another large section. Another standard deviation, we get a little bit, and a little bit, and then remember, we have, that gives us 99.7%, so what's left in this tiny little space here is 0.15%, and over here, 0.15%. Now, we discussed this in class, but just as a reminder, it's not that like this is the 4 standard deviation point. That just means it could be 4, it could be 5. It like that 0.15% is anything, is like the entire space that's above 3 standard deviations. So it could be within 4, it could be within 5, it could be like a really large outlier. It sort of depends on how the data is spread out. So, but it's just sort of in that, in that sort of, I guess, area that's left. So anything above 3 standard deviations or anything below 3 standard deviations is where that 0.15% is. So when we're talking about normal distribution, typically we look at 2 different types of questions. One is asking whether or not a data set is normally distributed. So that would be looking at either a frequency table where you use the standard deviation to make the bin sizes, or a histogram or frequency polygon to give you the shape. And so In either of those cases, what you're doing is you're evaluating how closely the data matches with the percents that they're supposed to be. So again, if you need to check that, it's on page 250 in the textbook. So that's one thing that they can ask. They can also ask us about a given set of data that we know is normally distributed, and then, what percent would you expect to have certain things happen? So that's the example we have here. We have the mean height of an adult man is 69.5 inches with a standard deviation of 3 inches. What percent of men are taller than 72.5 inches? So the first thing we want to do is just sketch out a normal curve. Doesn't have to be perfect, but just sort of to put in the benchmarks. So we'll start, the mean goes in the middle, so the mean is 69.5. And then we go up and down by 3 inches because that's the standard deviation. So 69.5, add 3, you get 72.5, 75.5, and 78.5. And we'll go down 66.5, 63.5, and 60.5. So they've asked us specifically about 72 and how many are taller. So taller would be this direction. So we would just need to add up what each of the sections should have in it. So this one is 13.5, 2.35, and then don't forget the 0.15. So in total, 16% of adult men are taller than 72.5 inches tall.